हेलो स्टूडेंट्स, तो इस वीडियो में हम देखने वाले हैं डेरिवेशन रूल नंबर 3 की। सबसे पहले एक बार फटाफट से रिकॉल कर लेते हैं कि रूल नंबर 3 एग्जैक्टली था क्या। इफ़ वी हैव डिफरेंशियल इक्वेशन ऑफ दिस फॉर्म एम डी एक्स प्लस एन डी वाई इज इक्वल टू ज़ीरो एंड द कंडीशन फॉर रूल नंबर 3 वाज एम इज ऑफ द फॉर्म y times some function of x times y and n is x times some another function of x y, right? And from this we saw that if this condition is satisfied, then integrating factor was given by 1 divided by mx minus ny. So now we will derive how we got this integrating factor. So let's start by taking integrating factor. Let's take an integrating factor as r of xy, r as a function of xy. This is our integrating factor, and let's just multiply this with our equation. Now what I'm going to do is I'm going to write m like this and n like this from now on. These are two different. So after multiplying with r, we will get our equation will become y f1 of xy times r of x comma y, right? And this whole is multiplied by dx plus x f2 of xy times r of xy dy is equal to 0. There shouldn't be any comma here. X and y are in multiplication, as I told you in the last video about this rule. तो ये लिखने के बाद नाउ अब हम देख सकते हैं कि दिस होल थिंग, ये पूरी की पूरी चीज़ इज़ अवर न्यू m. सो आई विल कॉल इट m डैश एंड दिस होल थिंग इज़ n. तो इसको हम बोल देंगे n डैश, राइट? नाउ द कंडीशन फॉर दिस टू बी एग्जैक्ट इज़ इफ़ अगर डेल m बाय डेल y अगर अब इक्वल हो जाता है डेल n डैश बाय डेल x के, then this will be an exact differential equation. So let's just take derivatives as usual. So before taking derivatives, we need to know a few things, which are, since this f1 is a function of xy, right? It is a function of xy, so we can also write it as a function of u, where u is actually xy. So now in this case, this is a composite function, right? f1 is a function of u and u is also a function of xy. So if we write, for example, del f1 by del y, if we take this derivative, then we have to use chain rule, right? So we have to write df1 by du, because f is a function of u, then take derivative of u with respect to y, du by dy. Now du by dy is clear, du by dy will be x, so this will become df1 by du times x. And similarly, when we take derivative of f2 with respect to x, this will become df2 by du and du by dx, which will be df2 by du times y, right? So I already told you these things because we are going to use this in this derivative. So चलिए इसको अप्लाई करते हैं. So we need to take this derivative first. So I guess we should copy this again. So let's copy and paste this. Yeah, so now let's take the derivative of this thing first of all with respect to y. So we will get different terms. We will get f1 of u, then we will get r, plus we will get y, then we will get that del f1 by del y term, then r, then plus y f1, then we will get del r by del y. and this should be equal to the derivative of n dash with respect to x. So this will again be quite similar to the left hand side, r plus x del f2 by del x, r plus x f2 times del r by del x, right? Now we will use these things which we found earlier, del f1 by del y and del f2 by del x, right? Here we derived them. So del f1 by del y, this thing can be written as del f1 by del u times x, and similarly this can be written in this form. So let's write these down. So this will be f1 r plus y, so this will become df1 by du, and then du by dy, which is actually x, and then r plus y f1 del r by del y is equal to f2 r plus x. This will become df2 by du, and du by dx will be y r plus x f2 del r by del x, right? Now one thing we can do is we can take these like terms together, like this and this, right? So we will get r times f1 minus f2, right? And then we can take these terms, are kind of similar, so we will get plus r xy is same in all these terms, so r xy, then we have df1 by du minus df2 by du, right? And let's bring rest of the terms as well here. So this will become plus y f1 del r by del y minus x f2 del r by del x is equal to 0. So actually this term right here, we can actually write it as a derivative of dy du of f1 minus f2, right? So let's just replace it with this term which I wrote down below. Let's just replace it here, right? So now we can see that we can't really solve this equation quite easily, mainly because of these, because we have r as a derivative of x and y, both derivatives are here. So somehow if we are able to get rid of these derivatives and we only have derivative with respect to any one thing, then we have some hope of solving this. So what we can assume, that let's assume that we have already seen that the we have already seen that f1 and f2 are both function of x times y, right? We know that. So let's assume that r is also a function of x times y. Instead of x comma y, it is also a function of x times y. So this is the assumption which we are making, which actually works out. That's why I am showing you this. Otherwise the thought process goes like this, that we assume that r is a function of xy in hoping that we are able to solve this differential equation. So let's assume that r is a function of xy. Now after this assumption, these terms, these del r by del y and del r by del x terms, these can be modified. How? Let's see. So del r by del x can now be written as dr by du, because xy was u. So the same procedure we used for this, the exact same procedure which we use right here, this exact same procedure we are using again. So if you have understood this, you will understand the r thing also, the process we are doing with the function r here. So this will become del r by del x will be del dr by du, and du by dx will be y, right? And now del r by del y will be dr by du again, and du by dy will be x. So now we can plug both these here, and after we plug both these here, let's write it down quickly. We have r f1 minus f2, we already have this, plus r xy, we already have this, sorry, it's time y, and we have this derivative of f1 minus f2, right? And plus, now what will happen here, let's quickly substitute these equations. So we will get y f1 and del r by del y. What is del r by del y? Is dr by du and multiplied by x, so let's write that x here. Then minus, we have here again x f2, and del r by del x is this, so it is dr by du times y. Let's write that y here. So again in this term you can see that we can take xy and dr by du common, and what we are left with is f1 minus f2 inside, right? So let's replace this exactly with what we just simplified it to. So let's take this and put it here. This whole thing is again equal to 0. Now a lot of nice things have happened here. First of all, we have this f1 minus f2 in all terms, right? This is quite nice. Secondly, everything is differentiated with respect to u now only, right? And third thing is that this xy which is multiplied here is actually u. Xy was u, this is u, right? So here we are going to do two things. We are going to write xy as u, and let's assume this f1 minus f2 is a new function g of u, of course, because f1 and f2 themselves are functions of u. So after writing this, we will get r g plus r u t by du of g plus u dr by du multiplied by g is equal to 0, right? So now from here we are going to take u common, and we can write this as u common d r dg by du plus g dr by du, right? And in fact this thing is equal to u times derivative with respect to u of gr, right? So let's write this all down. So our equation is now rg plus u d by du of gr is equal to 0. Now one important thing is while doing this type of calculation is knowing which thing is function of which variable, right? Like from here on, after this equation, everything is a function of u only. That's why we are able to do all these derivations and these compacting these terms, the compaction of these terms we are able to do only because of that. So anyways, now we have this equation, and now again we can see that we have this rg in multiplication in both terms. So we are going to again do another thing. We are going to say that this new function f is actually rg, right? So after this we will get f plus u d by du of f is equal to 0. Now this is quite an easily solvable differential equation, so let's solve this. So we will have f is equal to minus u df by du, and then we have df by f is equal to minus du by u. Integrating both sides, we will get ln f is equal to minus ln u. If we send this minus sign inside, we will get f is equal to 1 by u, right? So we have this f as 1 by u, but we saw that f was actually equal to rg, right? So f is equal to rg, which turns out to be 1 by u. and now this 1 by u is actually 1 by xy, right? So we will equate these two and we can now see that r is actually equal to 1 divided by g times xy, and we also know that g is actually f1 minus f2, so r is 1 divided by xy into f1 minus f2. Now we are almost there. We have found r in terms of f1 f2. Now we just need to convert it into m and n. So here I'm going to write it down in this box right here. We had that m was equal to in this m was of the form of y times f1 and n was of the form of x times f2. So we can write f1 is equal to m by y and f2 is equal to n by x here. Now we are going to take both of these and we are going to plug them here. So after doing that we will get r is equal to 1 by xy times f1 is m by y minus n by x. Now you divide this in the bracket and finally you will get r is equal to 1 divided by mx minus ny. So this is the integrating factor for converting them to exact differential equation, and you can see that this is exactly what we called as rule number 3, the integrating factor of rule number 3, right? So that's how we derive the integrating factor of rule number 3. It was quite an interesting derivation and quite involving derivation. We have to use that xy as a function of u and then derivative of u itself. So yeah, this was quite a nice derivation, and so I hope you understood this derivation, and I will see you in the next video.